Objective 3.4, I can write the equation of a function in factored and standard form from using the key features on a graph. In our previous problem, we talked about how we could take the graph of the polynomial, using the coordinates of the x-intercepts to start writing our equation in factored form, and using a point on the graph that we know the coordinates of and substituting them in for the input x and the output f of x and solving for our value for a to see the vertical stretch or any reflections that happen with our function. So we have our factored form here. In order to put it into standard form, we have to perform the operations that are being done here. So all these are being held together by multiplication. So we're going to multiply out our terms. We're going to combine the like terms and write them in descending exponential order, and we will have our equation for our polynomial graph in standard form. So again, when you're multiplying, you can only multiply two items at once. So I'm going to start by multiplying these last two terms first and keep multiplying that result by one other term and by one other term until I finally get my standard form. So if I multiply these two together, I'll get x squared minus 3x. Again, take 2 and multiply them together, and we're going to distribute accordingly. So I'm going to take x times each of those terms. So x times x squared will be x to the third. X times negative 3x would be a negative 3x squared. We then have to take our 2 times x squared, so we'd have a positive 2x, and, 2x squared, and 2 times negative 3x, that would be a negative 6x. So again, at this point, what we might want to do is combine some like terms. We've got some quadratic terms that we could put together. So a negative 3x squared and a positive 2x squared would be a negative x squared. And we're almost got our equation in standard form. We just have to distribute every term by 2. So it looks like our standard form for our function f of x is equal to 2x to the third minus 2x squared minus 12x. At this point, you always want to double check and make sure, well, is that really matching with the graph of the polynomial that we're working with? And it is a cubic. It's good that we have a cubic here. We can see that we've got a leading coefficient that's positive. So if you think back to the end behaviors for your cubic function, as x goes to negative infinity, so did your f of x. And as x goes to positive infinity, so did your f of x. And so here, right now, that's showing a match according to the graph's end behavior with our leading coefficient and the type of polynomial function with the polynomial graph.